Imagine you're a site owner with some solar PV installed on your premises, and you're wondering if adding a battery would be a smart financial move. To explore this, we'll use Gridcog to simulate a large commercial and industrial site located on the outskirts of London. The site has ample roof space, capable of supporting up to 2 megawatts of solar PV. However, due to grid congestion, the export limitation has been capped at 500 kilowatts. First, let's create a scenario by adding a battery in self-consumption mode. In this setup, the battery only serves the load and does not respond to external price signals. Next, we'll compare this to a scenario where the battery operates in co-optimized mode. Here, the battery not only charges from the solar panels and serves the load, but also responds to price signals to reduce costs and boost revenue. This means it will discharge to lower network charges during peak times, export when the prices are favorable, and charge when the electricity costs are low. Alright, let's dive into the results. First, let's examine the interval data for a typical week in June. Here, the blue line shows the electricity drawn from the grid, and the yellow line shows the energy generated from the 2 megawatt solar PV array. Due to the export restriction, the blue exports peak at 500 kilowatts. Now, let's show what happens when we add a 1 megawatt hour battery in self-consumption mode. This battery charges from XX solar and immediately discharges into load when the sun sets. Next, we'll introduce a battery optimized to price signals. In this scenario, the battery still charges from the solar, but also reacts to price signals. For instance, let's focus at 6:30 p.m. on the 21st of June. The price is high at this time, so the battery sees it as an opportunity to export and take advantage of the favorable price. Now let's look at the relative cash flows to see how this impacts the business case. The cash flows on the screen are for 1 year, excluding capex, compared to the baseline scenario with no assets. In scenario 4, the purple block represents ancillary services now accessible through a smart battery. Additionally, the savings from the network charges increase along with higher revenues from exporting during optimal periods. So that's another use case for Gridcog, helping you see your energy future clearly.